name. So we have an application that's saying there's a woman and her GPS location at the moment is in this restaurant, in this street. Feel comfortable? Doesn't feel comfortable to me either. So just think about these applications and the stalking implications. Really not a good thing to do, and it may or may not be in your functional spec, but I hope that from a professional perspective, you're looking a little bit more about this. So potential pitfalls then, look at what I call fidelity. Fidelity simply means truth. Is this true or not? Correlation means that when this changes, does this change? So if I change and vary this, does this go in sympathy with it? Does it tilt like this? Or does this change and this kind of stay still and then it does its own things? We need to understand, if we're looking at data, is there correlation? Is there a pattern between them? And then we're looking for causation. And software testing is all about this. I type in these inputs, I see this happening. We hope that's correlation, don't we? I did this, I see that. And then when we find a bug, we're looking for causation. When I do this, a bug occurs. Is it because I did this, or because of something else that was happening at the same time? And that's really important as a tester, is to understand, is it causation when I'm reporting a bug, or am I just reporting correlation? I did this, I saw that. Yeah, okay, fine, whatever. So potential pitfalls then. Who owns the data? Remember the data goes to a third party? You clicked through the agreement, didn't you? Because you were in a hurry. And it says, download our library in 5 minutes. And your boss was saying, we need it tonight. It will go out tonight, and you went click. Your boss comes back 6 months later saying, we need to use a new system now, because your bonus relies on the new system. Good. Who owns that data? Is it your data? Can you have it back? Please, can I have my data? Wasn't it my application? Oh, never mind. So you need to know who owns the data, because otherwise you may never see it again. And I mentioned about changing the yardstick. The yardstick comes from English. I went to a Bangalore school yesterday, and it had a rule in English and metric. The old measure was from the nose to the tip of the thumb of the king. That was the yard in England. So we had a constant measure until the king died. And the king, being like you, is a little bit shorter, so never mind. It's as simple as that. So I've talked a little bit about the libraries. I've given you some ideas of what it is. Let's see about applying the concepts. This is general software engineering practices in my view. And for those of you doing Agile, I think most of you put your hand up and say, yeah, we're doing some sort of Agile sounding thingy. We basically start by designing the events, implement, we look at the results by measuring them, and we make a decision. And we kind of iterate and repeat this. I don't know of anyone who's bright enough to design a perfect set of measurements the first time and every time. I assume that you're not brilliant, or at least not that brilliant. So we're not that brilliant, so let's just learn by doing and get the feedback. Here's some suggestions for the assessment criteria, the validation side of it. The colors come from this concept called Six Thinking Hats. It's popularized by a guy called Edward de Bono. I've talked about it in the years gone by. You can watch boring videos of me online if you care. So yellow is sunshine. So what are the benefits of using analytics? This is where we start from. If it has no benefits to us, why do we bother using it? White, what I consider a safety rating. Can I trust this library not to do bad things? Purple, fidelity. Purple is the color of the king. So ultimately, the king wants the truth out of this. Red, feelings of stakeholders. I gave you the example of this poor gullible woman who's using the application and now being tracked. How would she feel if she knew what was happening to her? How would we feel about it? Sorry, I repeated white because I was so pleased with it. Green, the eco rating. By this, I mean how many resources does it use? How much network traffic does it send? And then black, thinking through the problems, the privacy aspects, the risks of using this library. So analytics, then, we can use to look at the past. You're probably familiar with this, defect reports. What happened in the past? Well, last month we filed 37 bugs. 2 were priority ones, blah, blah, blah. Today, we might see something happening. We're looking at analytics reports, and we notice the number of exceptions being reported is going up really, really quickly. Well, what happened? Oh, we released a new version through the App Store. It was approved yesterday. Oh, let's think about that for a moment. We put a new version out. maybe new users are using it, we're seeing this climbing exceptions, perhaps we could do something about it today. Perhaps we can call the team together, the engineering team who built the app, and look at this problem today. Rather than waiting until we get bad feedback in a week's time from our users, we can investigate. And then we're trying to predict what will happen in the future. So the example I picked on you for, the growth curve. In the hotel I'm staying in, I happened to notice a piece of paper. It's advertising the job for head of catering. And I love this thing because it said, in month 1, you will deal with 20 lakh you'll bring 20 lakh of revenue. Month 2, you'll bring in 22 lakh. And month 3, you'll bring in 24 lakh. Great. Didn't talk anything about how the hotel was doing at the moment, or whether we're making a loss or not. And thankfully, most of you don't know the name of the hotel, but safe to say, I don't think they're making a lot of money in terms of service. So they're just saying randomly, we're going to predict it's going to go up, and you're going to make it happen. So great, but is that a safe prediction? Did they grow linearly? If I was going in there for the job interview, I'd say, what was last month? Was it 18 lakh? And the month before, was that 16 lakh? Okay, good. If I see a prediction like that, chances are, as long as I don't screw up, it'll keep going up. But if I think it was going down like this, and now they're asking me to make it go up, no, I'm not going to take this job. No. Oh, you're not paying me salary, are you? You're just paying me a bonus, aren't you? Yeah. Gullible. No, not me. So anyway, that's the information, and what we're trying to do is gain insights. So if we're looking at the past, we're looking at how and why did it happen. This is factor analysis or causal analysis. What caused the problem? What caused these exceptions to happen last time? Right now, we want to know what to decide, what to do next. Okay, we can see the number of exceptions are going up. Looks like a bad thing's happening. Do we pull the application from the App Store? Do we stop users downloading it? Do we get the team back who've just worked a 16-hour shift last night to come and investigate the problem? Do we call a new team together? What do we need to do to decide what to address the problem? And then in future, we're looking at predicting what's likely to happen, and particularly looking at what can go wrong in future. So that's how analytics can help us. It can help us not just with our applications, but also with the work that we're doing. This report is actually from Microsoft Research, and they're looking at software engineering teams. I'm just applying it to analytics, and saying, based on engineers at Microsoft, and Microsoft has quite a few engineers, and they're pretty good, can we predict how well they're writing code? So they're looking at it from a development perspective rather than from a pure analytics perspective. They're applying analytics to software development. So back to our mobile stuff. We've got our mobile app, we've got our mobile analytics client, and we've got analytic data. And we're getting the feedback on how well our app's doing, and the growth patterns, and the usage patterns. And we get some potential problems coming back, exceptions, perhaps, and we get patterns of usage. So can we use this to refine our testing? I was working with a company who have a global mobile application, it's multi-platform, and one of the testers saw the analytics data, probably for the first time, and he was really excited because he suddenly realized that about 40 or 50% of all the users were in Paris. Paris speaks, well, people there tend to speak French. Guess which language he was testing our application in? English. So now he realized that 40% of the usage at the moment is in French. If you were the testing manager, or if you were the tester, would you think about testing in French now? Maybe. Maybe it makes sense to test in French. And if you don't speak French, of course, you can solve that problem by hiring someone who speaks French. But we refine our testing based on the analytical data. Hopefully, we improve and fix the application. Otherwise, why are we bothering? And we go through this feedback cycle. So in terms of analytics, we get a nice virtuous feedback from the data that helps us refine our testing. It also helps us refine our development, of course. And it helps us to improve the product, which is the end goal. So I've just stolen my own thunder here, but here we go then. We're looking at bugs. How many know about Doc Graham's defect detection percentage, DDP? Doc Graham is one of the august speakers in our industry. August means old, by the way. So she's an august speaker, and she came up with this measure. It's not a perfect measure, but it's called defect detection percentage. There's a link to her slides. It's all online. And what it's saying is how many bugs did we find before we went live, and how many were reported after we went live? The ideal for us, probably, is we find most of the bugs before we go live, and hopefully we don't have too many appear after it goes live, because it implies our testing wasn't perfect. So it's a good measure of looking at that. As I say, it's an imperfect measure. There are flaws with it. Don't assume that just because the DDP is going up, that your world is perfect. It may be your users have stopped speaking to you because they hate you so much. So usage patterns, looking at the patterns through the applications. Some of you will be using personas. This is a concept that Microsoft use a lot as well, where you model what looks like a real person. It isn't, it's an aggregate person. But you say, and again, forgive me for picking on you at the front, but you model a pretty young lady in India who's in her 20s, young 20s, and beautiful, so I've got to be nice now, haven't I? So you model that, and every time we create test cases, we imagine what a pretty young lady, and we give her a name, we'll call her Vanessa. So what Vanessa would do using our application, and how would Vanessa feel about our application being used in these different ways when we make changes to it. We might measure the grumpy old man. That's me, by the way. Now I'm getting old, and I'm certainly grumpy at times. So the Julian, using our application, will be very different. And he's very intolerant, and he complains all the time. So when we're testing, we have a persona that's the Julian persona, and we use that to help improve our testing. We can use it for things like navigation. How do our users actually navigate through our application, web, mobile? And then we can replay that in our testing and perhaps our automated test cases to make sure we cover the common paths, the breadcrumbs going through the application. Localization, I've mentioned about the French, making sure we're testing the languages our users are using. And then we can also test more in production. So one of the things about DDP, which is where it has a flaw in it, is sometimes I deliberately want to do more of my testing in production because the value outweighs the risks. Google, Bing, all these companies test in production. Facebook tests in production. Read Goran Kabiedov's work, which is online, about Facebook testing in production. The games company, which is the article in Wired magazine, test. They do all their testing in production. So hang on a sec, sure that means the DDP is really poor, isn't it? Because all bugs are found after we've gone live. The difference is these companies react very quickly. The moment they start to see an adverse trend, they change something. And they change it so quickly that you don't even notice. When you visit a site like Google or eBay or Bing, and you go and type your search, 99 times out of 100 it just works. What happens when it doesn't work? It takes a bit too long. We just hit refresh, don't we? So in that refresh, you may have been redirected to a different system in a tenth of a second. It's that simple. If you design your systems that way, there's no real problem with doing that sort of testing in production. The risk is low. So the question is, what's the philosophy behind testing in production? I'm going to pick on you. You're my businessman at the moment. So remember this, because you're going to make more money now. Let's imagine that the development team, which are those people over there who are still awake, which is good. They're still awake, and they've just written the code, and this is the testing team, and you're one of them. The testing team says it's going to take us a month to test the application. And you're thinking, that's supposed to make me 20% bonus per month because of the uplift. Let's say you're Flipkart. You're the CEO of Flipkart. So they've just done the new release of Flipkart, and these guys are saying it's going to take us a month to test it. Hang on, what's the date today? 12th of July, 12th of August? So you're going to get no money from the new improvements they've made because these guys are going to take a month to test it. How much do these guys cost per day? Oh, $100,000 a day. So that's 100,000, 200,000. Oh, I guess that's 30, 100,000. Oh, that's a lot of dollars. A lot of dollars that you're costing and you're not making because you're waiting the extra month to not make a profit. You're not making the increased value. So the decision you make is, right, we're going to go live today. How much money do you make today because you've gone live with the new code? Well, if the code kind of works, you start to see a growth. Of course, if there's a problem, you need to fix it. And let's say that the cost of a bug happening is $5. What happens is the customer inadvertently gets charged for shipping, and they shouldn't do because they're an Amazon Prime type customer. So the bug is it costs you $5, and today 17 users were affected by it. 17 times $5, $85. Cost of rectification, which is a bit more money. So it costs you $200 to solve the problem because you launched today, but you made $1,000. $1,000 plus, $100 minus, $900 plus overall. Is that good? Okay, good. You can buy your Maserati a day sooner. So I'm just trying to give you a real example of this. These companies are saying, well, we can't wait for testing. It takes too long for testing. So testing needs to be rethought if we're testing in production. Because the focus for a tester testing in production is to try and make sure the experiments are correct in production. If something bad were to happen in production, how would we know? How long would it take? How quickly can we rectify a problem if it happens? It's a very different focus from, I'm going to test this and find all the bugs before it goes live. So this is the way the industry is moving generally, and it's because of good financial and commercial reasons. And of course, if this team is a pile of crap and they wrote the worst, buggiest application ever, well, you're probably fired anyway, so you don't care. And to be honest, these guys probably wouldn't have found the bug, so whatever. No, but seriously, of course, you've got to think about the quality aspects. And that's one of the reasons why companies have experiments, and they'll typically do what's called a canary. A canary is a bird that was taken down to mines, and the thing about a canary is it dies quicker than a human being does with poisonous gas. That's all it does, it dies. And the reason we want it to die sooner is because otherwise we die first. We're pretty sort of selfish, aren't we, ultimately, as human beings? So the canaries went down the mines. If the canary died, they simply ran. Screw this, I'm gone. You want me to dig coal? Well, that's tomorrow's problem. You fix the gas, and then we'll go back and dig the coal. So the canaries in technology is saying we'll put the new version of the software out to a couple of servers, out to a couple of users, and see what happens. If we see that it seems to be going okay, we'll send it to some more users. Mobile has some complications with this because you're dealing with app stores. I won't go into the details of that, but just remember that mobile, you've got some complications with this. Web, this is trivial. You put it on one server, you put it on two servers, you watch the servers, you compare it to the existing ones. This is an A/B experiment. You then roll it out to 20% of your user population. How's it going? Oh, it looks like it's pretty good. We're seeing a little bit of a high exception count here. It's using slightly more memory. Is that good or bad? Well, we can live with that because a new server costs us, I don't know, $1,000 compared to it making $3,000 in new application. Okay, well, we'll buy 10 new servers, and then we'll get the development team, those lazy buggers over there, to optimize the app and fix the problem that's using the memory. But for now, we'll just put more servers on the problem. So that's how they run the business much more. So, go on. Great. Yes.
Now, normally what I understood is these experiments are going to detect for you which is a better spec change. The changing of specs and which is a better approach.
Yes.
They are really not going to help you in detecting software bugs.
So I'll repeat the question shortly. So I think you're saying that my statement was that experiments are generally used to detect which is the better choice and not to help find bugs. You find what you look for, and you tend not to find too much of what you're not looking for unless you're lucky. So most companies, at least the technology companies I've worked with, is that they want to know how their software is performing in production from an engineering perspective as well as a business perspective. So what they'll be doing is they'll be running memory checking on all the servers individually on a 1-minute basis. They'll be checking probably 100 to 1,000 other key metrics. So when we're running an experiment where we've got the button on the left or the right, we're also looking at the exception counts. And we're looking at it assiduously. Anyone who's worked, I say anyone, but virtually anyone who's worked in a Linux environment is familiar with the system logs. And you just learn to look at the system logs. It's the first place you'll go and check. When my USB thing doesn't work, I go and look at the syslog. So when my applications have an exception, I look in the syslog. So you learn to look in the logs, and that tells you more about what's happening. So we can use experiments in production of saying, we'll try something in production, we'll try it. Does that make sense? Let me move on because of time, and I'll take questions at the end. So back to testing and analytics. I've mentioned this, but I think our responsibility is to check that the analytics libraries, the tools that we're using, the way we're using them, are actually worth using. They're faithful, reliable, and we can trust them. And then when we have the confidence in the tools,